Today, we are going to talk about a great scientist called John Dalton and his contribution in chemistry known as the Dalton's atomic theory. John Dalton was an English chemist born on the 6th of September 1766 and died on the 27th of July 1844 at the age of 77. His religious beliefs and perhaps his modesty prevented him from accepting much of his deserved fame and recognition. Today, Dalton is known primarily for his atomic theory, although his inquisitive nature and diligent research led him to make many important discoveries in fields other than chemistry. He also made a careful study of color blindness, a condition from which he suffered. Dalton was also a pioneer meteorologist, keeping daily records of the weather for 57 years. His fascination with the weather and the atmosphere led to his research into the nature of gases, which in turn became the foundation on which he built his atomic theory. Dalton's atomic theory. John Dalton published his theory in the year 1880s about the atoms, and his main assumptions or postulates of his theory include 1. All matter consists of indivisible particles called atoms, matter being anything that has mass and occupies space. Example, a man is an example of matter. And in a man, we have tiny indivisible particles called atoms. Another example would be a bottle. A bottle contains tiny indivisible particles called atoms. Therefore, anything on earth that has mass and occupies space contains tiny indivisible particles called atoms. Furthermore, atoms of the same element are similar in shape and mass but differ from atoms of other elements. Let's consider the case of the element carbon. In the element carbon, looking at the picture, you will notice that all the atoms have a similar shape and mass of 12, but they are different from atoms of another element like chlorine. In chlorine, all the atoms have a similar shape and mass, but they are also different from atoms of the element carbon. Atoms can neither be created nor destroyed. Atoms of different elements may combine with each other in a fixed simple whole number ratio to form compounds. For example, we have an atom of hydrogen, another atom of hydrogen. So we have two atoms of the element hydrogen combining with an atom of the element oxygen in a ratio of 2:1 to form a compound known as water. So, in the compound water, we have 2 atoms of hydrogen and an atom of oxygen combining in a ratio of 2:1. Atoms of the same element can combine in more than one ratio to form 2 or more compounds. We have 4 atoms of hydrogen combining with 1 atom of carbon in a ratio of 4:1 to form the compound methane. In the next case, we have 2 oxygen molecules combining in a ratio of 1:1. The oxygen molecules combine with the methane compound to form a compound known as carbon dioxide and another compound known as water. In carbon dioxide, we have 1 atom of carbon combining with 2 oxygen atoms in the ratio of 2 for the oxygen atoms is to 1 carbon atom to form the compound carbon dioxide, and in the water compound we have 1 oxygen atom combining with 2 hydrogen atoms to form the water molecule. So, the combination is in the ratio 2 for the hydrogen atoms is to 1 oxygen atom. So this reaction describes how a compound methane reacts with 2 oxygen molecules to form 2 compounds, carbon dioxide and water. This combination, as you can see, is in more than 1 ratio to form more than 1 compound, because looking at the picture, you will notice that 2 compounds have been formed, carbon dioxide and water. Atoms are the smallest unit of matter that can take part in a chemical reaction. Atoms cannot be seen with the naked eyes. You need to use a microscope or some other instrument in order to observe atoms. It is important to note that this theory had some drawbacks which we are going to treat in this section. The indivisibility of an atom was proven wrong, for an atom can be further divided into proton, neutron, and electron. The proton and neutron are found in the nucleus, while the electron is found in the shell. However, an atom is still the smallest particle which can take part in a chemical reaction. According to Dalton, Atoms of the same element are similar in all respects. This was also proven wrong because atoms of the same element vary in their mass and density. Such atoms of the same element having different masses are called isotopes. Example, we have the element chlorine. The element chlorine has two isotopes, that is chlorine 35 and chlorine 37, thereby proving the above postulate wrong. Dalton also said atoms of different elements are different in all respects. This has also been proven wrong in certain cases like argon and calcium, which have the same atomic mass of 40. Such atoms of different elements that have the same atomic mass are called isobars. This theory completely failed to explain the existence of different properties. We have the element charcoal, diamond, and graphite. They are all made up of the same kind of atom, that is, carbon atoms, but they have different properties. Nevertheless, this theory also had some merits, which we are going to discuss in this section. It has enabled us to explain the law of chemical combination, which says atoms of the same element will combine in a fixed number ratio to form compounds. Dalton was the first person to recognize the distinction between the ultimate particles of an element and compounds. In elements, we have tiny particles called atoms, while in compounds, we have molecules. Thus, John Dalton is often considered to be the father of modern atomic theory. Thanks for your kind attention.